Hi, everybody. It's Professor Mitchell, continuing with Chapter 10. In this video, we'll look at Section 10.3 on amortization of loans. Loans under consideration will be repaid in a sequence of equal payments at regular time intervals, with the payment intervals coinciding with the interest periods. The process of paying off such a loan is called amortization. A mortgage is a long-term loan used to purchase real estate. The real estate is used as collateral to guarantee the loan. And before I forget, I should mention that there is some heavy-duty number crunching in this section, so you will want to have your calculator handy. The repayment process is as follows. Payments are made at the end of each interest period. The interest to be paid each interest period is the period interest rate I times the unpaid balance at the end of the previous interest period. The unpaid balance at the end of the interest period is the previous unpaid balance plus the interest owed for the current interest period minus the payment. As an example, suppose that a loan has an interest rate of 12% compounded monthly and a term of 5 months. First, given that the principal is $563, we'll calculate the monthly payment. Next, given that the monthly payment is $116, we'll calculate the principal. And then finally, given that the monthly payment is $116, we will calculate the unpaid balance after 3 months. The sequence of monthly payments constitutes a decreasing annuity with the monthly payments as rent and the principal as the present value. Notice that N is equal to 5. And I is equal to 1% or 0.01. That's because the annual interest rate is 12% and it's compounded monthly. So using the formula for a decreasing annuity that we developed in the last section, which you see here, we're going to substitute 563 for P and 0.01 for I, and N equals 5. Which gives us 563 is equal to 4.853 blah, blah, blah times R. So dividing both sides by 4.85343 blah, 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 we get that R is equal to $116. Please ignore the sloppy notation down here at the bottom. If you just take out that multiplication sign, then it's correct. You have one step here and then the answer here. Or you could just cross out the times R, and that works too. All right, so for letter B, using the same formula, here we're substituting 116 for R, and P is unknown. So the principal would be 1 minus 1.01 to the power negative 5 divided by 0.01 times 116, which comes out to $563. So really in this example, we're just practicing using the formula. And then for letter C, the unpaid balance is the present value of a decreasing annuity of 2 payments of $116. So N is going to equal 2. I is still 0.01, R is still 116, and the unpaid balance after 3 months, otherwise known as P, would be 1 minus 1.01 to the negative 2 divided by 0.01 times 116, which would be $228.57. All right, in the next example, on December 31st, 2010, a house was purchased with the buyer taking out a 30-year, $328,781 mortgage at 4.8% interest compounded monthly. First, we'll calculate the amount of the monthly payment. Then we'll calculate the unpaid balance of the loan on December 31st, 2036, just after the 312th payment. Next, we'll figure out how much interest will be paid during the month of January 2037. Then how much of the principal will be paid off during the year 2036. How much interest will be paid during the year 2036. And what is the total amount of interest paid during the whole 30-year mortgage? All right, big problem. So first we'll denote the monthly payment by R. Then 328,781 is the present value of an annuity of N equals 360 payments, with I equal to 0.048 divided by 12, which is 0.004. Therefore, using this formula, R is equal, which is, I should point out, if that formula looks upside down to you, I will admit that this is a little confusing the way they wrote this. Normally, the formula is P equals 1 minus 1 plus I to the negative n over I times R. So what they've done is they've just written the formula in a different form, but I promise you it is equivalent. Okay, so using that formula or the formula that we're used to, I encourage you to try it the other way and see that you get the same answer. R comes out to $1,725. So the monthly payment would be $1,725. For letter B, the remaining payments constitute a decreasing annuity of 48 payments. So the unpaid balance, using this same formula, would be found as 1 minus 1.004 to the power negative 48 divided by 0.004 times 1,725, which is $75,200.08. The interest paid during 1 month is I, the interest rate per month, times the unpaid balance at the end of the preceding month. Therefore, the interest paid, one moment, please. Okay, there we go. Wanted to fix the typo that was there a moment ago. The interest paid in January 2037 would be 0.004 of $75,200.08, which was the balance left at the end of the preceding month. And that comes out to $300.80. For letter D, since the portions of the monthly payments applied to repay the principal have the effect of reducing the unpaid balance, this question may be answered by calculating how much the unpaid balance will be reduced during 2036. Reasoning as in Part B, we determine that the unpaid balance on December 31st, 2035, just after the 300th payment, is equal to $91,854.30. That would be a good one for you to try. Just double check that that is correct. It's just like in letter B, except there are 5 years of payments left instead of 4 years. Okay, so you would use the same formula that we used in letter B, except N would be equal to 60 instead of 48. Therefore, the amount of principal repaid in 2036 is equal to the unpaid balance at the end of 2035 minus the unpaid balance at the end of 2036, which comes out to $16,654.22. All right, moving on to letter E. During the year 2036, the total amount paid is 12 times 1,725, which is $20,700. But by Part D, $16,654.22 is applied to repayment of principal. And so the remainder is being applied to interest. So that amount is $4,045.78. And then finally, the total amount of money paid during the 30 years is 360 times 1,725, which is $621,000. Since the principal is $328,781, the rest is being applied to interest, which is $292,219. So one big takeaway from this problem, in case you didn't know, is whenever you take out a 30-year mortgage, you do end up paying quite a bit of interest. But that, unfortunately, is how most people are able to afford owning homes, all right, when they're able to afford that. So just something to know. All right, that brings us to successive unpaid balance. If P dollars is borrowed at an interest rate I per period, and R dollars is paid back at the end of each interest period, then this formula, which you have seen before, B sub new equals 1 plus I times B sub previous minus R, can be used to calculate each new balance from the previous balance. For example, on December 31st, 2010, a house was purchased with the buyer taking out a 30-year, $328,781 mortgage at 4.8% interest, compounded monthly. So the same scenario that we looked at in the last example. So now we'll calculate the unpaid balance of the loan on January 31st, 2037, just after the 313th payment, using information from the previous example. In the previous example, the unpaid balance at the end of 2036 was $75,200.08, and the payment is $1,725. Therefore, using the formula that we just looked at, the remaining balance at the end of January 2037 would be $73,775.88. All right, and then for the final topic in this section, we'll look at balloon payments. Sometimes amortized loans stipulate a balloon payment at the end of the term. For instance, you might pay $200 at the end of each quarter year for 3 years, and an additional $1,000 at the end of the third year. This $1,000 is called a balloon payment. Balloon payments are more common in commercial real estate than in residential real estate. For example, how much money can you borrow at 8% interest compounded quarterly if you agree to pay $200 at the end of each quarter year for 3 years, and in addition, a balloon payment of $1,000 at the end of the third year? So the way that we deal with a problem like this is as two separate present value problems. So we're borrowing in the present and repaying in the future. The amount of the loan will be the present value of all future payments. The future payments consist of an annuity and a lump sum payment. So we'll calculate the present values of each of those separately. So first, for the $200 payments, the annuity, we'll use this formula to find that the present value of those $200 payments would be $2,115.07. And then using the regular future value formula that we talked about, I believe that was 2 sections ago, The present value of the balloon payment is the future value divided by 1 plus I to the power n, which is, all right, needed to fix another little typo there. That comes out to 1,000 divided by 1.02 to the power 12, which is $788.49. Therefore, the amount you can borrow is $2,115.07 to cover the quarterly $200 payments, plus $788.49 to cover the balloon payment, for a total of $2,903.56. All right, so to summarize, a mortgage is a type of loan that is paid off in equal payments at the end of regular time periods. P, the principal, is the amount of money borrowed in a loan. R, the rent, is the periodic payment on a loan. At any time, the balance of a loan is the amount of money needed to retire, that is, pay off the loan. It is calculated as the present value of all future payments. A payment used to retire a loan is called a balloon payment. And successive balances of a loan can be calculated using this formula. And that's going to do it for section 10.3. We'll see you next time.